Hello dear students, this is discussion of JEE advanced question papers of previous years from Eigen Learning. We are discussing questions from JEE advanced 2022 paper 2. Coming to this question, in physical chemistry, an aqueous solution is prepared by dissolving 0.1 mole of an ionic salt in 1.8 kilogram of water at 35 degrees Celsius. The salt remains 90% dissociated in the solution. The vapor pressure of the solution is 59.724 millimeter mercury. Vapor pressure of water at 35 degrees Celsius is 60 millimeters of mercury, and the number of ions present per formula weight of the ionic salt is. So it is a numerical sort of question. You have to find the number of ions present per formula weight of the ionic salt. Number of ions present per formula unit of the ionic salt. This is a simple question from the chapter Solutions concerned with the topic related to lowering of vapor pressure. Now let us go through the data. What you have to find is the number of ions present per formula unit of the ionic salts. Assume that it is X. If that is assumed as X, then the Van der Hoff factor, it's an ionic salt which dissociates, and therefore the Van der Hoff factor is 90% dissociation that is given. So if the number of ions present per formula unit of the ionic salt is X, then the Van der Hoff factor I will be given by 0.9 into X, 0.9x plus 0.1. Isn't it? So that is the Van der Hoff factor I. It is 0.9. Why? Because it is 90% dissociation. X is the number of ions present per formula unit. So 0.9 into X plus 0.1 will be the Van der Hoff factor. And in the case of a solute which undergoes dissociation, considering also the Van der Hoff factor, the Raoult's law for a dilute solution may be written as P0 minus Ps by P0 is equal to I into mole fraction of the solute. Mole fraction of the solute, that is I into chi B. If B is the mole fraction, if B is a solute, chi B is the mole fraction of the solute, then relative lowering of vapor pressure is equal to the Van der Hoff factor multiplied by the mole fraction of the solute. So you can substitute P0 is 60. So what you get is 60 minus 59.724 divided by 60 is equal to, that is equal to I 0.9x plus 0.1 multiplied by the mole fraction of the solute. So 0.1 mole of solute divided by 0.1 plus the number of moles of the solvent. It is 1.8 kilogram of water, that is 1800 gram water divided by 18, the molecular mass of water. So when you subtract this, you get 0.276 by 60 is equal to 0.9x plus 0.1 multiplied by 0.1 divided by, this will be 100, so 100.1. Okay? So that is approximately 100.1 can be taken as 100 itself. So if you bring this 100 to this side, what you get is 0.276 into 100. Okay, or as to be exact, it is 100.1 divided by 60 into 0.1 is equal to 0.9x plus 0.1. So that's the result that you get, and from this you can calculate the value of x, and you will get the value of x as 5. X will be equal to 5. We will get the answer. This is the equation from which you can solve it. Now suppose you take this as 100, it will be 27.6 by 6, 27.7 by 27.6 by 6 is equal to 0.9 plus 0.1. You can easily solve and get the result, and you will get the result as well. So the problem as such is simple. Only thing is that you have to be cautious about the Van Hoff factor in this case, because it is an ionic salt undergoing dissociation. So the 90% dissociation, it is given in the problem. So you have to write the Van Hoff factor, and the Raoult's law now becomes relative lowering of vapor pressure is equal to I into mole fraction of the solute. Mole fraction of the solute is number of moles of the solute divided by total number of moles. Total number of moles, it is 100 plus 0.1, that is 100.1. And for purpose of calculation, you can take it as 100 itself. So for 0.276 into 100, that is 27.6 by 60. 27.6 by 60 is equal to 0.9x plus 0.1. You can solve and get the value of x. So the problem is simple, isn't it? It's a very simple problem. Only thing is that you have to be careful about the Van Hoff factor coming into the picture in the calculation. Okay?